Okay, for this lesson, we are using similar triangles. And you're going to find whether two triangles are similar by checking out their angle measures, or you're going to determine what the angle measures are if it in fact tells you that the triangle is similar. So triangles that have the same shape but not necessarily the same size are considered similar. So you look at these two triangles right here. This one is considerably smaller than the other. But we're not concerned about the side lengths, we're just concerned about the angles. If you look at all three angles, they are the exact same angles as the corresponding triangle. So these two triangles would be considered similar. All right, so let's look at example 1. All right, so what we're going to do with these two triangles is decide whether they are similar. So in order to do that, we are going to find the missing value. So in this case, you see we have on the first triangle, the missing value is x. So to find the missing value, you add up the three interior angles, and you know that all three added up always equal 180. So 75 plus 50 plus the missing value x equals 180. Now we're going to simplify and solve for x. So 75 plus 50 would be 125. So you rewrite that, plus x equals 180. Now to get x by itself, you need to subtract that 125. So 125 moved over to the other side would give you 180 minus 125, which leaves you with x equals 55. So now let's find the missing value over on the second triangle. Notice that so far it's looking good because we have a 50 and a 55, and we just found out that the value for x in the first triangle is 55. So let's see if y ends up being 75. So again, we put y plus 50 plus 55 equals 180. We're solving for y, so we're going to add the 50 plus 55 to simplify. So then you get y plus 105 equals 180. Now to get the y by itself, you have to subtract 105 from both sides. So you get 180 minus 105, which leaves you with y equals 75. So now you can see that the three different angles are 50, 55, and 75. This means that these two triangles are in fact similar because they have the same angle measures. Okay, let's look at B. We have two other triangles here, and you can see that you have the little red corner, which means that's a 90 degrees, and then each one gives you a different angle degrees, so we're going to have to solve for each of the missing angles again. So for the first one, I have 90 plus 42 plus x equals 180. I add the 92 and 42 to simplify, so I get 132. Now to get x by itself, I need to subtract that 132, so I have 180 minus 132, which when you subtract that, you should get x equals 48. So our missing value over there is 48. Now you can see over here that our other angle was 38, so it's not looking real good. But let's double check and find the measure of this missing angle. So again, we have the little red box, which means 90. So we have 90 plus 38 plus y equals 180. So we're going to add the 90 plus 38. So you're going to get 128 plus the y equals 180. Now to get y by itself, we're going to subtract 128 from both sides. So 180 minus 128 is going to give you y equals 52. So in this case, we do not have the same measurements because one triangle has 90, 42, 48, and the second triangle has 90, 38, and 52. So they do not have similar angle or same angle measures, so these two triangles are not similar. All right, let's look at, I believe we're doing the on your own next. All right, I'm going to go ahead and put both of these out here, but we're going to start with doing number 1. So for number 1, I should make these smaller because we need space to do this. All right, that should be good. Okay, so for on your own number 1, we have 2 triangles, and we're going to tell whether the triangles are similar and then explain it. So you're going to either say yes or no, and then tell me why no or why yes. So for these 2 triangles, we've got to solve for the missing value again. So again, I'm going to do 28 plus 80 plus x, and then all 3 angles of a triangle add up to 180. Sorry, that came out to be a funky 0. So I'm going to simplify, and I'm going to add these 2. So 80 plus 28 is going to give you 108 plus x equals 180. See if that does better. Yep. So now to get x by itself, I'm going to subtract the 108. So I get x equals 180 minus 108. So you should get 72. Now you can go ahead and look at your second triangle and see, is this going to match up? No, it's not, but we can solve it just to be safe. So we have, I'm going to run out of space for writing so big, I'm going to try and squish it. 28 plus 71 plus y equals 180. So 28 plus 71 to simplify is 99 plus y equals 180. So now I'm going to subtract the 99. So 180 minus 99 gives you 81. So that 81 would correspond to where this y is, which you see here is 80. So for on your own number 1, you're going to say no. They're not similar because the triangles do not have the same angle measures. I'm going to type it. Because that will fit a whole lot better than me handwriting it. Okay, so no, because the triangles do not have the same angle measures for number 1. So now let's do number 2. I'm going to use green on this one. So for number 2, again, we have that 90 degrees, so we're going to say 90 plus 66 plus x equals 180. 90 plus 66 will give you 156 plus x equals 180. So subtract the 156. I'm left with x equals, what's 180 minus 156? You should get 24. Looking good because you can see our corresponding angles 24. But again, let's double check. So I'm going to do the second shape, which you see the 90. So I'm going to say 90 plus 24 plus y equals 180. 90 plus 24 gives you 114. So then you're going to do 180 minus 114, because that's how you move it to the other side, and you're going to get 66. But you look up here, that was the same as the other side. So both of these have our 3 angles, 90, 24, and 66. You can see it in both equations. So for this one, let me get my typing tool. You would say yes, the triangles have the same measures, and then you would list the triangles. So you're going to say 90, I don't think I have a little degree sign on this thing. Whatever, 90 degrees, 66, and 24. So that would be how you would explain these 2 triangles. So there's on your own number 1 and number 2. So let's go look at example 2. Okay, so again, make sure you're writing these examples in your journals, and then you've got the on your owns on your separate piece of paper. So you plan to cross a river and want to know how far it is to the other side. You take measurements on your side of the river and make the drawing you see in the picture. Explain, for A, why triangle ABC and DEC are similar. And then B, what is the distance X across the river? So if you look at these two triangles, you can see that they both have the 90-degree right angle. And then for the tall side on the ABC triangle, you see it's 60 feet. And on the bottom or short side, you see that triangle CDE is 40 feet. So we're going to try and see if these two triangles are similar by showing whether the angles are congruent. So first things you're looking at, B and E are both 90 degrees, so they're both right angles. So those are definitely congruent. Look at angle C there in the middle. When you have an X formed, that's called a vertical angle. We've gone over this. Vertical angles are definitely congruent. So because of this, we know that all three angles are going to be congruent. So that we know a triangle ABC is congruent to triangle DEC. So these two triangles would be considered similar. Okay, so for your explanation, you just need to talk about how you have angle B and E being right angles, so they're congruent. And then where angle C is, it's a vertical angle, so then the third angle has to be congruent if the first two are congruent. All right, so for B, it says, what is the distance across the river? So this is where we're trying to solve for X. You see where X is on this diagram? So we're trying to find the length of the tall side of DEC. Well, we just proved that the angles were congruent, so now we can set up a ratio. Ratios of the corresponding side lengths are equal. So you can say that X, that missing value of X, is corresponding to the tall side of the other triangle, so X over 60. And then the short triangle, you got to use the same triangle on top, is the 40, and then the base of the other triangle is 50. So here's your proportion. X over 60 equals 40 over 50. Now you just cross multiply and divide to solve for X. Okay, they just moved the 60 over, but you can cross multiply and divide, you'll still get the same answer. So X equals 48. So you know that the distance across the river is 48 feet. All right. If you have any questions on this one, please send me a message. Remember, we proved that the triangles were similar because of the angles being congruent. Once you knew that, you could set up a ratio to find the missing side length. You had the corresponding sides. Let me see if I can circle that. So this side has to correspond to the tall side here, and then the bottom side corresponds to the bottom side of this one. So that's why you got this ratio of X over 60 equals 40 over 50. All right, so let's move on. All right, so we're going to look at on your own number 3. Put this on your papers. So what if, in example 2, the distance from vertex A to vertex B is 55 feet? So I'm going to go grab that picture from example 2 that we were using. Don't need it that big. And let's discuss our changes here. Okay, originally the length from A to B was 60. They're saying from A to B is now 55, so change that to 55. And then it says, what is the distance across the river? Well, remember, we could set up a ratio because we had proven that these were proportional. So we can say this vertical length is X over, and then you match it, so that's going to be 55. And then the other ratio, remember we got to start with the same triangle, would be 40 over, and then this base length is 50. So this is where you can cross multiply and divide. So you have 40 times 55 divided by 50. All of my little drawings make it hard to see, so I'm going to take these off. 40 times 55 divided by 50 gives you x equals 44. So then this distance across the river is 44 feet. Remember, we have to label this as a word problem. Okay, so we had already proven this, so all we did was change our ratio to the new length because they told us the new height here was 55 feet. Good. All right, I believe that's all of our examples for today. Yep. So you have all your on your owns done. So for your assignment, since you've already finished OYO 1 through 3, you need to do the practice and problem solving numbers, just 3 through 11. Should be pretty short and easy for you guys. All right, let me know if you have any questions.